Okay, we retain another integral. This one's from the UNSW Integration Bee 2024, round 2, problem 1. We have the integral from 0 to pi of e to the x times cosine x dx. Okay, to get started with this, when we have this situation, this comes up a lot when we've got e to the x times cosine x or e to the x times sine x. And usually a good way to do this is going to be integration by parts. So I'm going to come over here and we'll do the DI method or tabular integration in order to clean this up. So first, it really doesn't matter which I choose because each of these functions is going to persist. So I like to integrate e to the x and I'll differentiate cosine x. And we'll go ahead and we'll just do this a few times. So first, differentiating cosine x, that's going to give me minus sine x. And then we'll do it again. Alternating signs here. Derivative of sine x is going to be minus cosine x. And then integrating over here to the right, integral of e to the x is just e to the x, and we'll do it one more time. And now the reason I stop here at this last line, the last row is going to be an integral, and let's just notice that our original integral repeats. So when we take the minus sign out, we've got our cosine x and ex here. So we'll take part of the solution on the diagonals to start. I'm going to factor in e to the x out of this. So we'll have e to the x in front. Here, minus times minus is plus, so this is going to become just cosine x plus sine x, and that's just going to be evaluated 0 to pi. And then dealing with this integral here, let's just kind of put a label on our original integral. We'll call it capital I. So everything we're doing here is capital I. And then this here is going to be just minus I. So we'll put that here at the end. We're going to have a minus I that we're including with this. And before we deal with this, let's just evaluate this from 0 to pi. So what's going to happen is first evaluating at pi, we're going to get an e to the pi in front. Cosine of pi is going to be minus 1 plus sine of pi, that's just 0. So that's nice. And then we'll evaluate at 0. What we're going to have is we're going to have e to the 0, which is just going to be 1. Cosine of 0 is 1. And then sine of 0 is just 0. And again, we're just going to have this minus I at the end. But now let's get rid of that because we want to solve for I. This is our goal here. So what I can do is let's just add an I on both sides. If we do that, they're going to cancel here. If we add an I here, I can write this in front as just 2 copies or 2i. Then cleaning this up, we're going to have e to the 0 is just 1, so that's going to go away. And so what you can do is just kind of distribute and finish this off. So we're going to have minus 1 times e to the pi, so we're going to have minus e to the pi here, and this is just going to be a minus 1. Then I can divide by 2 on both sides just so we can isolate I, divide by 2 here. And I think what I'll do is just factor a minus 1 out of this, so I'll write a minus in front. So if my final solution is, we just have minus e pi plus 1 over 2, and that's it. Okay, there you have it. Quick and easy problem from UNSW 2024. Thanks everyone for watching. Have a good day.